Have you ever just stopped to think about the numbers we see all around us? It turns out they're all part of this huge, interconnected family with a really fascinating story. So in this explainer, we're going to build that family tree from the ground up, and we're going to start with just a simple walk.
Okay, so imagine this. We're going for a walk on the number line, and we've brought a bag with us. The goal is simple. Collect every single type of number we can possibly find. And trust me, this little journey is going to reveal the entire structure of the mathematical world in a way that just makes sense.
All right, our quest begins. We're starting at 0, and first we're just going to walk in the positive direction. The first numbers we find, they're the most familiar ones of all, the ones we all learned as kids.
So as we walk, we pick up 1, then 2, then 3, and on and on and on. You know the counting numbers. This collection literally goes on forever. And in the math world, we call them the natural numbers, and we use the symbol n. Our bag is already starting to fill up.
So we've already collected an infinite number of numbers, which is pretty good for our first few steps. But if we look back to where we started, we realize we missed something really important. We walked right past 0.
So we just turn back, scoop up 0, and toss it into our bag. And just by adding that one single number, we've actually upgraded our whole collection. It's not just natural numbers anymore. Now we've got the set of whole numbers, which we label with a W.
Okay, now for the other direction. We head back past 0 and into the negative side of the line. And what do we find here? Well, it's like a perfect mirror image of the numbers we just collected. -1, -2, -3, and on, stretching way out into infinity.
So, of course, we add all of these negative numbers to our bag. Our collection now has all the positive whole numbers, all the negative whole numbers, and 0 right in the middle. This complete set, that's what we call the integers. And a little fun fact, the symbol for it is Z, which comes from the German word zahlen, which just means to count. Pretty cool, right?
So, we've walked in both directions. We've collected all the whole numbers, positive and negative. It feels like we've made some serious progress, but our journey is far, far from over. We've got to look a little closer at the line itself.
And that brings us to the big question. We have all the integers from negative infinity all the way to positive infinity. It really seems like we should have everything, doesn't it? Is our bag finally full?
Nope, not even close. If we were to zoom in on the line, we'd see that between any two integers, like between 0 and 1, or 200 and 201, there are these huge gaps. And those gaps are just jam-packed with numbers like 1/2, 3/4. There's a whole universe of numbers we've totally missed.
So we get back to work, scooping all of these fractions into our bag. These are called rational numbers. The official definition is actually pretty simple, but it's super powerful. A rational number is any number that you can write as a fraction, p over q, where p and q are both integers. Now there is one crucial non-negotiable rule. Q, the number on the bottom, can never, ever be 0. Because, dividing by 0 breaks math.
And get this, the name itself is a giant clue. Rational comes from the word ratio, and the symbol for the set, Q, that comes from the word quotient, which is just what you call the answer to a division problem. See? It all connects.
One of the coolest things about rational numbers is that they can wear all sorts of disguises. The number 1/2, for instance, marks the exact same spot on the number line as 2/4 or 10/20, or even 47/94. They all look different, but they're all just different names for the very same value.
Okay, our bag is getting ridiculously full now. I mean, we have every integer and every single fraction that could possibly exist between them. It really feels like we must have captured everything this time. But, well, the history of math has a major plot twist waiting for us.
So let's ask that key question one more time. We have all the integers, we have every possible fraction. Our bag must surely be full now, right? Have we finally captured every single point on the number line?
And the answer is, incredibly, still no. Even though we have an infinite number of rational numbers crammed in there, there are, unbelievably, still an infinite number of tiny little gaps that we haven't filled yet.
And this isn't some new discovery. This goes all the way back to around 400 BC, with the Pythagoreans, the followers of the famous Greek mathematician Pythagoras. They're the ones who stumbled onto a type of number that basically shattered their entire understanding of the world.
See, they proved that there are numbers out there that simply cannot be written as a fraction of two integers. It's impossible. And the very first one they found was the square root of 2. This discovery was so upsetting to their whole philosophy that, according to legend, the guy who revealed it, Hipparchus, was thrown into the sea for spilling the secret.
These new kinda spooky numbers were given a name: irrational numbers. And the definition is just the polar opposite of a rational number. It's any number that cannot be written down as a simple p over q fraction.
So if it's not a fraction, where does a number like the square root of 2 even live on the number line? Well, we can pinpoint its exact location using some beautiful, simple geometry. Just draw a square with sides that are 1 unit long. The Pythagorean theorem tells us the diagonal has to be the square root of 2. Then you just swing that length down onto the number line like a compass, and bam! Where it lands, that point is the square root of 2. It's a real place, but it's not a rational number. So now we know we have two totally different kinds of numbers filling up our line. We've got the rationals, all the fractions, and the irrationals, the ones that can't be fractions. So let's finally put these two giant collections together and see the complete picture.
We go back to our bag one last time. To all those rational numbers, we now add this whole other set, all the irrational numbers, like the square root of 2 and pi, and so many others. And with that final step, every single gap on the number line is finally filled. Our collection is now, at long last, truly complete.
This massive, unified collection, this is what we call the set of real numbers, and we label it with an R. Back in the 1870s, mathematicians proved something profound. There's a perfect one-to-one match. Every single point on the line is a unique real number, and every real number has its own unique spot on the line. And that's why we call it the real number line.
So we've done it. We've built the entire real number line from its most basic pieces. But this leaves us with one last really interesting question. The square root of 2, which is irrational, has a decimal that goes on forever without repeating. But 1/3, which is rational, also has a decimal that goes on forever. So how can you possibly tell them apart just by looking at the decimal? Well, that is a story for another day.